Hi guys, welcome back to Sun Mathematics, and this is question 2 on a continuation of some math problems on an assignment regarding piecewise functions. So hopefully this is beneficial to whoever might be listening at whatever time, and hopefully I can know what to do with the math and be helpful as a type of teacher as I continue making these videos. But yeah, go ahead and click the timestamp that's in the description below for the start of the question. It's piecewise functions that has quadratics in it. It's got like a parabola. Yeah, go ahead and do that because I'm going to be setting up my camera on my tripod and taking a few bites of this bowl of fruits. Yeah, it's pretty good. Okay. Now I just have to get the angle. Let's see how that looks. Okay. Yeah, that's not too bad. It's kind of better than last time. Alright, so this is what the problem looks like. And actually, the picture I'm looking at, this extends farther with an arrow, but I'm going to make it stay looking like this just so I can bring up an example of what to write over here. Like an example of what it means to have an arrow at the end or to just have it like stop like this. So I hope it makes sense what I'm talking about here. The real problem that I'm looking at, the question from the person who sent me this assignment, it actually extends further and has an arrow. And the arrow basically just means that the graph is continuing to go on and on for like eternity that way, and it's going on and on for eternity this way, but when there's a point, that means it stops right there. That's important for piecewise functions. I don't know if you guys saw the first video I made when I did piecewise functions. I think I'll title it like question 1 or episode 1, and this is episode 2, like a continuation. Not exactly sure what I'll do, but in that video I talked about like with the piecewise functions how you need to write the domain from what range the graph looks a certain way up until it changes to being a different equation. So the first thing we want to do is identify how many equations are in this, and there are 3. One is this equation that makes the graph look like a curve, like a parabola. The second one is this horizontal line right here, and the third one is this line that's going like this at an angle. So there are 3 different equations. So first, let's just identify what these equations are on their own. So that equation there, let me see if you can see this. I hope you can. Okay, real quick, that curve, if we were to draw it completely on its own, would look something like this, where this point is 1, 1, and we'll call this point, it's not in the correct proportion, but whatever, 2, 4, and this is the point 3, 9, and the ones over here, since it's a mirror, since it's a parabola, they're all the same exact point. So this one is -1, 1. This point over here is -2, 4, and this one up here is -3, 9. The equation for this is y equals x squared. You can see when you plug in 1 as x, 1 squared is 1, 2 squared is 4, 3 squared is 9. So I hope that's all making sense. Depending on where you're at with this is a whole different subject. to do the piecewise functions, I need to just assume that you guys know how to do this. But then if not, of course, always feel free to leave a question below that you're having troubles with this in general as a concept, as a topic, and I can totally do a video on how to figure out quadratic equations and how to make a graph out of them. And I knew it was this one exactly because when I look at this one here, I can see that it goes to 1, 1, and on the left side it goes to -1, 1, -2, 4, which is -2 squared equals 4. That's it. It satisfies this equation here. So I know that this equation is x squared. So I'm just going to call this equation 1, this one equation 2, and this line equation 3. So equation 1 is y equals x squared. Now we need to find what equation 2 is. It's going to be y equals something. So this one's really simple because it's just a horizontal line. All you need to do for a horizontal line is look at the y value that it's at, and it's at the value of 3. So this is y equals 3. It's as simple as that. It's like no matter what x value you're at in this equation, it's always going to be a horizontal line. So if we were to show that one on its own, and this is the point y3, the equation would look like this. So see how, like, no matter what plot point you put x on, the y value is always going to equal 3. So x doesn't even matter, basically. So that's why this is the equation y equals 3. Hope that made sense. Again, if you're having difficulties graphing and knowing how to find equations to linear equations, sorry, definitely leave a question below as well on that, and I can do a whole different video on that one. But assuming that made sense, y equals 3 is your equation number 2. And then equation number 3, this one is a line at an angle. So this one, we do need to redraw and kind of figure out when exactly it reaches this one. I can already see that this one is just y equals x, but that's because if I were to, let me see if you can see here. Yeah, you should be able to see here. Okay, that is because if we were to draw it out on a different graph, and I'm just going to start with reference over here. So this is the plot point 2, 2, and that's the point 3, 3, and that's the point 4, 4. So I'm just going to start there on this one. So 2, 2, 3, 3, 4, 4, and it's a vertical line going this way. I'm basically just going to draw backwards and see where the y-intercept is. That's 1, 1, and then it reaches 0, 0, and it goes down that way. I just know that anything that goes directly through the origin, it matches up really perfectly, is always the most standard or basic equation to something. This is the most basic linear equation. This is the most basic quadratic equation. Y equals x squared. Y equals x. If this line was moved up or this way, or it was a different slant that didn't go exactly a 1-to-1 ratio the whole way through, you know, like 1, 1, 2, 2, 3, 3, 4, 4. If it was like going up double that speed, like 1, 2, 2, 4, 3, 6, you know, a different slant, a different angle, then this would be like y equals 2x or something. It would be different, is what I'm trying to get at. But anyways, that's how I know equation 3 is y equals x. So now we just have to write that over here. So you don't need to write the y equals part. The y equals is the f of x here. This f. Oh no! Almost dropped my phone, but it's okay. I did not. So yeah. you don't need to write that part because it's already written. So you just need to write the right side to all of these equations. So I'm gonna write x squared, and I'm just gonna put a comma, 3, and a comma, and an x and a comma. And the only final part you need to do here is list where on the graph is it these specific equations and for how long. So that's why it's important if there's a plot point like this, or if it goes off like an arrow. If it's a plot point, you have to say it starts or ends at that plot point. But because there's an arrow, I know that this actually goes to negative infinity. So the first thing I'm gonna write here on the side is that x is in between negative infinity and 1. That's where this parabola stops. It stops at the x point 1. See how it stops at the x point 1, but on the left side it never stops. It goes to negative infinity. So that's why I wrote it like this. And these dots that are like colored, filled in, and then these holes right here that are not filled in, this is important because it's saying that, see how this is 1, 1? This right up here is not actually 1, 3. It's like 1.000000001, 3. It's like the point after this one. So I hope that makes sense. And if not, of course, once again, leave a question below. But that is going to have a lot to do with when you use less than or equal signs, or if you just use like the less than sign. So I'm going to use that x point 1 is less than x. Notice how I wrote less than x and I did not write less than or equal. It's because there's a hole here. It's saying it's not actually at that 1 point. It's just after that point. So I hope that made sense. And then that is less than or equal to the x value of 2. And again, I'm using the less than or equal part because there is a filled in dot here. It does include the x value of 2. So then the last domain, that's what these are called. Domains is like the range, the boundaries, the borders for how long each equation lasts. So the domain for the third equation starts with the number x equals 2, or it's right after that actually, so it's just another less than sign without the equal underneath it. Then I put the x in between, and this is going to be less than or equal to infinity. And that would be the answer to question number 2, this right here. It's as simple as writing these ones down, but it can take a lot of needing to know how to know the equations to each of those 3 different equations, as well as needing to know how to write the domain down, which can be really confusing and take a lot of like, what does that mean? If a negative infinity is less than or equal to x, and x is less than or equal to 1. Like, even when I say that, I'm like, what? But I just see this as x is in between 2 numbers. And it's in between the number 1 and the number negative infinity, which goes that way. So there's that whole range there. So what might be helpful for you is to like maybe get 2 things and create vertical walls to where the equations go for. And you'll see, you start with here if there's a point, like pretend there was no arrow and it did just stop at this dot right here, then you could put this right here. And that is your domain, those numbers. This is -2 and that is +1. So you would write, as an example here, -2 is less than or equal to x is less than or equal to 1 as your domain. But because there is an arrow that goes to negative infinity, this is not a -2, this is actually negative infinity. So yeah, that method might actually be helpful for you, because if you see like creating these, I'm not sure if you're able to see all that, but when you do that, you can see the domain of everything. And then just always keep that rule of thumb that if there's an arrow, it means it's not actually stopping at wherever your paper is. It actually does go for infinity, whichever way it's going. So yeah, I hope that was a helpful tool to figuring out domain. You basically just need to figure out the smaller number and the bigger number, and then you just put X in the middle of that, and you just use less than or equals signs if there are like bullet points or arrows, and you use just the less than signs. You don't put the equal underneath it if there are holes like these ones, like this hole right here. I'm not sure if you guys can see it. This hole, that hole. When it's like that, you put less than signs. When it's like solid, like this one right here, that one, and this one, those are less than or equal signs. And same with arrows. Arrows are also less than or equal signs. Yeah. Okay, so that was question number 2. Woo! And it's 2:30 p.m. All right. I am wishing you all well. Wow, I don't know how I talked for 16 minutes. These are supposed to be short. So I hope that was time well spent. If anyone was able to get through that, take care. Peace out.